Hello everyone, this is online Intro to IT tutorial. Yesterday we conducted offline tutorial and there we promised to share with you solutions. So now we are recording video solution. It will be really short. We're going to discuss only solutions, okay? So, this test promise, as told you yesterday, you have to read the lecture notes and then you will be able to successfully solve them. These test problems, from 5 to 4. And now let's discuss problem number 5, okay? For that, I'm going to open here these notes and I'm going to write the problem. So it's going to be 5th, okay? This X, it's NAND, yeah, Y, NAND, X, NAND, Y. And as I've told you before, yesterday also, we have to firstly select which operator we're going to change. We're going to change this NAND to AND, okay? So now, for the first thing, we just write negation, open the brackets, and here we write the operator. This is going to be changed to this one, okay? I hope it's pretty understandable. So now we write this as A, denote as A, and this as B, we write here A and B. So now this equals to X, Y, K, and X and Y. And in fact, as you can see here, these two are same, yeah? A, okay? So as you know, A and A is equal to A. So now we can simplify this part, we can delete this part, okay? So now we have just A and negation A, and we write A, this one to here, so it's going to be this one. And now we're going to substitute this to, this to what? To N. So I'm writing from here. This negation, I open the bracket. If you want to change this operator, firstly you write negation and you open the bracket. What will be the outcome? To what operator do we change it? So we change it to AND. So operands are X and Y. To substitute this and bracket, these negations will be cancelled. So finally you have this value, okay? So this was problem number 5. We're going to discuss now problem number 7. I'm just writing explicitly the question. You have to simplify this expression. Excuse me for background noise. Unfortunately, I couldn't find the empty room to record this video. So please try to understand. If you have some problems with this sound, just write in the comment section. Okay. So I'm going to change firstly this operator. So I'm writing here what negation. I open this. I substitute this as A and this as B, and I write here that what will be to what it will be changed. This NOR, it will be changed to OR. Okay, so OR. Let me delete this. Okay, you know it. Just for avoid misunderstanding. So now on and or excuse me, it's OR. Yeah, it's OR. This is NOR. So now I write the operands A and B. So in fact, I then substitute, the values of A and B. So it's going to be negation. A is X nor Y, and or X nor Y. And in fact, as you can see, these two operands here are same. It's also A, X nor Y, X nor Y. So as you know, A or A is also A. In fact, A and A is also A. So I just ignore this part. Okay, I write negation just A. Okay, brackets. Okay, this brackets negation A. So I substitute the value of A back again. This was, A is what? A is X nor it's X. Okay, I hope my writing is pretty understandable for you. X, Y. So X nor Y. Okay. So now we continue from here. It's going to be what? Negation. I want to substitute this nor to OR. So negation I write negation, open the brackets, write the, the operator, the operator that will be after getting, after substituting this NOR. It's going to be what? It's going to be, okay, OR, okay? I write OR, and I write operands, X and Y. So in this case, these two negations will cancel, so final outcome is X or Y, okay? Hopefully it's pretty understandable for you. So now we move to question number 8, okay guys? So question number 8, it says X, Y, X or, and then negation inside there, X and Y. So in this case, as you know, in this problems, we have two operands, and these two operands were actually expressions, okay? This is operand. See, this is operand of this NOR, okay? But in fact, if you consider this separately here, this is what? This is not operand, this is expression, right? So, as you know, for simplicity, when substituting this NOR to OR, we're gonna declare it as A1 operand, okay? So now my point is that in problem number 8, this is already given, so you don't change it, okay? So this is also given. This is what? This is OR, and no need to change it. Okay. So this is done. This is done. So we are going to what? We are going to open this bracket. Okay. Open this bracket. This. So what will be the outcome? So X or I'm opening the brackets, okay? See, this is a formula or rule, okay? Say rule. If there is A or and B, for example, doesn't matter, it can be also or, okay? You open the brackets, you write A, negation B, and if there is and, it's going to be what? Or, okay? And if actually, for example, there was or, it's going to be and, okay? In this case, it's and, so I write here or, okay? So I'm coming here, I'm writing negation X, negation Y, and there is and it's going to be or, okay? In fact, it is this, sorry, let me write it a little bit differently, this, okay? So hopefully it's clear up to now. I am writing here this expression. So X or Y. So in fact, let's consider this separately. X or negation X, it's always 1. And you may say, why? Let's consider, let's say that X is 1. So X or this one, negation X, is going to be 1, or negation of 1 is going to be 0, right? 1 and 0, it's going to be 1. For or, in order the outcome to be 1, it's required only one operand to have 1, okay? To have input 1. So let's consider X is 0. So now, this is going to be what? X is 0, or, but negation of X, negation of 0, it's going to be 1. So 0 or 1, it's 0. Okay, we can substitute this as 1. So 1, okay, 1 or negation Y. So in this case, see, as you know, in order outcome, see, in order outcome, output, let's say, output to be 1, or, okay, or operator has to have at least one true value. Its true value, it's 1, okay? So there is already 1, so it doesn't matter whether it's Y 0 or 1, it is always going to be 1, okay? Because this is a formula, or this is a rule of OR operator. I hope it's pretty understandable. So we are moving to the next problem, and this problem is going to be the problem number Okay, 11. I hope everything is clear up to now. So I'm coming to problem number 11. As you can see, there's a problem saying that this is 40 Cyrillic letters, 10 English letters, 10 punctuation characters, and 10 5 emotions. So in UTF, 8 Cyrillic letters require 2 bytes. English letters, punctuation letter, characters, and letters, require 1 byte. And emotions require 4 bytes. So overall, 40 multiplied 2, 10 multiplied 1, plus 10 multiplied 1, and plus 5 multiplied 4, it's going to be 120, okay? Yeah, so let's come to this problem, convert minus 11 to 8-bit 2's complement notation. Okay, here we go. So problem number 11, okay? So, sorry, it's problem number 12, floating point. So, okay, we're given minus 11. We want what? 2's complement, yeah? 2's complement, I think, yeah, 2's complement. So, firstly, you have to convert 11 to by a 2's complement, okay? How to convert decimal to 2's complement? You have to keep dividing, okay? Keep dividing to 2. For example, 11 divided by 2, it's going to be 5, 10, 1, and you keep dividing until you get as a remainder 1, okay? So remainder is, until you get the outcome here 0, okay? Until 0, keep dividing. Keep dividing by what? Keep dividing by 2. This means until a result is not 0. So it's not 0. 5 divided 2, it's going to be 2, 4, 1. 2 is not 0. So 2 divided by 2, it's going to be 1. It's going to be 0 result. And 1 divided by 2, because 1 is not 0, it's going to be 0, 0, and 1. So outcome is 0. So stop here. So we're going to read the value from the down to the up. So that means 11 equals to 1, 0, 1, 1. But you have to write in 8-bit notation. So that means you have to write for the, in the place of, you see, there's 8 bits are given in the memory. 1, 3, hopefully it's clear. So we got this value. We're going to write this value from the end. So now we have 4, this 4 bits empty. So to this empty bits, you have to write 0. So because you are asked to write in 8-bit notation, but if you're asked to write in 4-bit notation, this is enough. This is answer. So 11 equals in 8-bit notation 0, 0, 0, 1, 0, 1, 1. But this is in fact 11, but we are asked to find minus 11. So in order to find minus 11, what do you do? Okay, let's find minus 11. You write 11's value. This is 0, 0, 0, 1, 0, 1, 1. And you read from the right, okay, until you meet first one, right? Not this right, okay. Right, the point is that you have to traverse until you meet the first one. You have to copy all bits. So copy all bit values, okay. I'm going to explain it. So I have met first one, so this is done. So then once you have met first one, you have to inverse value, okay, other values. That means 0, if you met 0, you have to write this as 1. If you have 1, you have to write this as a 0, okay. For example, next bit is 1. I'm going to write this as a 0 because I have already met the first one, okay. So 0 as 1, 1 as a 0, and 4 zeros I'm going to write as 4 ones, okay. So this is in fact equals to -11 in two-speed notation. This is decimal. So I hope it's pretty understandable. If you have any kind of questions, you can ask in the comment section. So let's move to the next problem. So next problem is going to be about actually reading Huffman quote message. So see, you are given this Huffman tree, and you're given the keys. So how to decode this, okay? Huffman code in order to find out the message. Actually, see, you have here code. Okay, let's start reading. I mean, it's one. Yeah, firstly, it's one. So if it's one, you go right. Okay, you are going right. So then it is 0. Okay, I'm going to the left, and then you're going to 1. It's 1. So you from 0 you're going to 1. So it's D. D. See, it's going to be D, and in fact, what can I do? I'm going to write also here, for example. I mean, okay, sorry. So 1. Okay, see, I'm going to write the code here. So 1. Okay, let's don't write this again. Rewrite this again. So I'm going to read. Okay, firstly. Right. So firstly, it's 1. Okay, here it's 1. So 1 means go to this side. Okay, so 1, and then 0. 0 means go to the left. So I'm here. Okay, so then what? I'm here. So then read after 0. I mean, I'm going to 0. There is 1. So go to the right. So D. So this means D. So that means you eliminate, you don't look at this part, okay? You have already read this key. So now we are going to read the rest of the code as similar as it is. So that means you're going to start each time you have to, each iteration you start from what? From root of 3, okay? Root of 3. Start what? Reading code, okay? Let's say reading code, okay? Reading code. So now we are starting from 1. So go to the right. So again 1. I'm writing here 1. Again 1. See. Again 1. So go to the right and see. You have met the letter. So you stop there. Okay. 11. I mean 11. It's going to be E. So that means stop when you meet letter. Okay, and go there again. Okay, it's kind of loop until till the end of what? Till the end of what? Code. I mean 0, 1, etc. Okay, until the end. So hopefully it's clear. So let's quickly read the rest of the values. So I'm going to eliminate this 11, 11. So now I'm going to start from what? From 0. Okay. So if 0 means go to this side left, and then there is 1, go to the right, and I mean okay, this 1. So again 1, go to the right, 2 ones, again 1, go to the, I mean 2 ones, okay, again 1, just stop here. Yeah, okay. Sorry, actually, yeah, it's correct. I have to write 1 more again. So here, we start from 0, go to the left, and then 1, yeah, 1, this one, go to the right, and then again 1, go to the right, and then again 1, go to the right, so you meet what? N. So this code means N. So you eliminate this part, the code that you have already written, okay? I mean, written means written, okay? So let me delete this quickly. And then we start from here. So 1, what does it mean? 1, go to the right, and then 0, go to the left. Here, I mean 0, and then again 0, go to the left, just stop, U is met. So 1, 0, 0, okay? It's going to be U. Let's finish quickly this part. And then again, we're going to start from the beginning. Now we're going to the left because it's 0. And then 1, it's going to right, okay? And then 0, it's going to the left. So 1, what's going to be? X. So your message is this, damage. So that's it. So now let's move to Next problems. Okay, two's complement. I have already explained the two's complement. See, what's first you do? What's the very first thing that you do? Because read carefully. Question. There is minus 10. The very first thing that you do is to convert 10 to floating, not floating point. Two's complement. Okay, two's complement, and then convert 10 to what? Minus 10. Okay, and then this 13 converted to two's complement, and then you can add 13 plus minus 11 minus 10. Okay, so actually let's do it. Okay, let's do it. Hope it will be understandable for you. So 10, what's going to be 10? It's like 15. 10 is going to be what? It's 8-bit notation. First I write 444, and 10 is 1010. Okay, I'm going to convert it to minus 10. So I read until I made the very first one, 0, 1, and then after this one, I'm going to what? I'm going to inverse these values. For example, 0 becomes 1, 1 becomes 0, and 4 zeros become 4 ones. Actually, this is minus 10. So what's going to be 13? 13 is going to be what? Actually, first 0 zeros, because it's 8-bit notation, and then 1 1 0 1. So minus 10 is going to be what? Minus 10 is going to be 1 1 1 1 and 0 1 1 0. And then I'm going to plus them. Okay. So 1 0, it's 1, 1 0, 1, 1 0, it's 0. We have 1 carrier, 1 1 0. So 0, okay, 1. Overall, what we're going to have is just zeros, okay? Because you will have 1 carrier, and carrier will be kind of overflow, and you don't write it, okay? Because no memory for carrier, okay? So this is the answer. Let me write here 0 0 0, okay? Dot, I mean dot, just for your simplicity. Don't. It's, I mean, first 4 bits, and then 0 0 11. Actually, I can delete this dot. I mean, I hope you understand it here. Okay. So this is the answer. It's A, I guess. So let's now move to the next problem. So quickly. So here we are. So I hope you understand this problem. Just ask Sarvar Abdullaev, actually, why this is so. Okay, and just ask Sarvar Abdullaev why this is so, because this can also be true. This can also be true, but to do some research. Do some research. Search. In fact, C is true. They may seem to be true, but one condition change everything. Okay, one condition change everything. That means there's one condition that doesn't let them to have overflow error. Okay, change everything. Just ask Sarvar Abdullaev to do some research again. So let's move to what? To next problem. So, you know, I'm going to explain right now this problem, converting decimal to floating point, and the rest of thing. I mean, this problem you can do on your own, okay? Because they are similar. Okay. So let's move to the problem number 17. So what's asked here? Actually, what? Actually, let's read it. Just forgot. Okay. You have to convert this floating point, this decimal to floating point. Okay, but the very first thing that you have to do is to convert this decimal to what? Actually, you have to convert it to, firstly, binary fraction. Okay, so let's move as given 3, 2, 3, 4. So firstly, to binary fraction. Okay, so in order to convert to binary fraction, you consider integer and fraction parts separately. Okay, integer part is here 2. Convert 2 to this binary. It's going to be what? 2 divided 2, 1, 0. You keep dividing until you have here 0. Okay, divided 2, it's going to be 0 and what? And what? And 0, 1. Read from the down to up. So 2 is going to be what? 10. Okay, so I put here dot. I write here fraction part. Fraction part. So fraction part is going to be 3 over 4. You have to keep multiplying it to 2 until you get 1. Okay, so multiply by 2, you're going to have 3.2. Okay, but you have to write it. You have to write it divided into integer and fraction part. 3.2 is 1 and 1.2. Okay, 1 over 2. Okay, 1 plus 1 over 2, and here you write what? Only integer parts you have found. Okay, so you write here 1 because you have found that 1 is integer part. So keep dividing 1 over 2. Then you consider only this part. You can get it, and remove it to here. I mean, got it and move to here. So now you only have fraction part. You keep dividing fraction part with 2, and then you make to 1. So that means stop, and just move it also here. Okay, it's pretty easy. So now we have 10 1 0 dot 11, and this is binary fraction. So what I'm going to do right now is to convert it to floating point. Okay, floating point notation. The very first thing that you have to do is to move this dot to the leftmost, what? To the leftmost first one. Move dot, okay, dot to the leftmost, the very first, okay, leftmost, very first one. Put it before it, okay? Put it before it. So in order to move this dot, I have done 1 operation, 2 operations here. So a k is 2. That means number of steps to move dot, okay? To move dot. Actually, in floating point notation, you're going to have in this problem 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. The very first bit is for sign. The following 3 bits is for exponent, and the last 4 is for mantissa. So sign is going to be 0 when number is positive, 1 when number is negative. So here number is positive, so right here 0. And now you have to find exponent, right? So how you find exponent? Exponent is equal to k. This is number of steps to move dot to 2n minus 1. What's n? Is the size of memory, okay? Memory size given for exponent. So how much memory is given for exponent right now? 1, 2, 3. So in this case, n is 3 because only 3 bits are given for exponent. So k is 2. Yeah, if you have more 2 times. So now exponent equals to 2 plus 2 to the power 3 minus 1, 2 plus 2 to the power 2, and it's going to be 6, right? So exponent is going to be 6, and you have to write 6 in the format of binary in 3-bit notation. So 3 is going to be what? 3 is going to be 1, 1, 0. Hopefully it's clear, right? 0, 1, 2 here. For example, 2 to the power 2 is 4. 1, actually it's not. So stop. Actually, is it clear? Is it right or not? So actually, see, this is 4, this is 1, and this is 6, right? Or is this 7? Yeah, it's just 6, yeah, right. Hopefully this is 6. I cannot forgot actually. So okay, This is going to be 1 sub 1 1 0, right? Okay, so right here 1 1 0, and you have to find right now mantissa is really simple, and here you got this, right? And then really is what this, and you have 4 bits, and this is mantissa. Okay, for example, if you have here also 0, you omit 0 because you have to take first 4 bits, first 4 values. So you write it here 0, I mean 1 0 1 1. So yeah, that's it. This is the answer. Answer is 0 1 1 0 1 0 1 1. So let's check it. Okay, this was problem number 17, and you should have converted it to what? To hexadecimal. Please just convert it. It's pretty easy, right? For example, you have 8-bit. Firstly, you consider 4 bits separately. For example, in here, you should have get as a hexadecimal 6, and here it should have been B, okay? So we have only 4 minutes left, so let's be quick. So I think this can be solved pretty easily. So let's now consider this algorithm, how to read this algorithm. So you are given that x is 0, y is 1, space is 2. So we rewrite it, okay, as a code. So instead of x, I'm going to write 0. Instead of y, I'm going to write what? 1, 1, and see. This algorithm is pretty smart. If you have met new expression, for example, y is new expression, right? Y is new expression. So it will kind of give to it code, and next time to write it as 3, okay? So algorithm now knows that x is 0, y is 1, and space is like 2. But once you map new expression, it's going to add to dictionary new expression and assign it to the next integer value. It's going to be 2 plus 1 is 3, okay? So next time when we meet y, we're going to write instead of y, it's 1 1. I mean, here we write 1 1, 3, okay? New value. So let's continue. Space is going to be what? Space is going to be 2. X is going to be what? It's going to be 0. Y is 1. X is 0. And there's space 2. And then there's x is 0. And then there's y. Instead of 1 1, we don't write 1 1 because our dictionary has now assigned already new value for it. So we write what there was actually 0 actually, because it is x. So instead of this y, we write now 3, as you can see here. And now yeah, that's it. We read actually this. We have read this. Okay, stop, let's don't confuse. Actually, we are here, right? We are here. So we write 2 here, then x, 0, and then instead of y, we're going to write 3, and there's a space 2, and there's space 2, right? Actually, see, and then yeah, and then we're going to write actually 3. So right, then you get C, right? So it's pretty easy to understand. So in this case also, so now you have to construct new, I mean, you have given this code, you have to kind of write expression with xy's. So instead of 1, what do you write instead of 1? Instead of 1, you write, actually, you are given that instead of 1, you write y, okay? Yeah. Instead of y, you write y, and then again y, and next time when you meet y, you're going to write 2 because dictionary assigns to this new value 2, right? Okay, so y, and then there's 0, it's going to be x, there's 2 space, right? Space, and you're going to write anything, and then we meet what? And we meet again 3. What's 3? 3, and it's 3 is going to be 0 y, okay? Dictionary has assigned new value y. So now as you can see here, then it's going to be x, etc. Pretty easy, right? So actually I have left less minutes, less than 1 minute. So this was end. I hope it's pretty understandable for you. If you have any kind of questions, please ask. We're going to make second part of this video where we will explain this Brookshire machine, okay? This Brookshire machine. So please stay tuned and see you soon in our next tutorials.